The direct method. Welcome, everyone. Before we dive into today's new topic, let's take a moment to reflect on what we have already covered. In our previous lessons, we mastered how to calculate the mean for discrete frequency distributions, where each value is clearly defined. However, today we are stepping into a slightly more complex area: grouped data. Now, when you see data organized into class intervals, you'll notice a challenge. We cannot directly use these intervals in our calculations because an interval, such as 10 to 20, represents a whole range of possible numbers rather than a single, specific value. This makes it impossible to perform standard arithmetic directly on the range itself. To overcome this, we use what is known as the direct method. This method provides a clever solution by using the class mark. Think of the class mark as the midpoint of each interval. By using this single, representative value to stand in for all the observations within that class, we can proceed with our calculations accurately. Let's move on to the next slide to see the specific formula we will use to apply this. Understanding the formula. Now that we understand why we can't use the raw intervals directly, let's look at how we actually perform the calculation. You'll find that the direct method uses a formula very similar to the one we used previously for discrete frequency distributions. To put it simply, the mean, which we denote as x bar, is calculated by taking the sum of the products of the class marks and their corresponding frequencies, and then dividing that entire sum by the total frequency. Looking at the screen, the formula is expressed as x bar equals the sigma of f sub I times x sub I all over the sigma of f sub I. Let's break down exactly what each of these symbols means so there is no confusion. First, x bar represents the arithmetic mean of our group data. The x sub I represents the class mark of the ith class interval. Remember, that's the midpoint we discussed in the previous slide. The f sub I represents the frequency of that same ith class interval. The notation sigma of f sub I times x sub I denotes the sum of all those individual products we are about to calculate. And finally, the sigma of f sub I represents the total number of observations, which is just the sum of all our frequencies. Now, I want you to take note of a very important point here. The mean we calculate using this method is actually an approximate mean. It isn't perfectly exact. This is because, in our calculation, we are making a mathematical assumption that all the individual data points hidden within a specific class interval are concentrated exactly at the midpoint, or the class mark. As we move into the next slide, I will show you the systematic steps you need to follow to apply this formula correctly. Step-by-step calculation process. Now that we understand the logic behind using class marks to represent our intervals, let's break down exactly how to perform this calculation. To find the mean using the direct method, I want you to follow these 5 systematic steps. First, you need to find the class marks, which we denote as x sub I for every class interval in your table. You'll calculate the midpoint. You do this by taking the upper limit, adding it to the lower limit, and then dividing the whole sum by 2. Second, once you have your class marks, move to the next column in your table. You will multiply the frequency, which is f sub I, by its corresponding class mark, x sub I. This gives you a new value, which we write as f sub I times x sub I. Third, once you have completed that multiplication for every single row, you need to calculate the sum of products. This means you add up all those values you just calculated to find the total sum of f sub I times x sub I. Fourth, you must also find the total frequency. Simply add up all the frequencies in your frequency column to find the total number of observations, which we represent as the sum of f sub I. Finally, the 5th step is to apply the formula. You will take that sum of products we found in step 3 and divide it by the total frequency we found in step 4. This final division will give you x bar, which is our calculated arithmetic mean. In the next few slides, we are going to put this exact process into practice with a real-world example involving student weights, so keep these steps in mind. Real-world example. Now that we understand the theory and the formula behind the direct method, Let's put it into practice with a real-world scenario. Imagine a teacher is recording the weights of 30 students in a class to analyze their overall health. Instead of looking at each individual weight, the data has been organized into grouped intervals. Our goal here is to calculate the mean weight of these students using the steps we just discussed. If you look at the data table on the screen, you'll see the weight intervals in kilograms on the left and the number of students, which we call the frequency, on the right. For example, in the first group, 5 students weigh between 40 and 45 kilograms. To solve this, we need to follow the systematic process I outlined in the previous slide. The very first step is to find the class marks, which we denote as x sub I. Remember, we can't use the range itself, so we need that single representative midpoint for each interval. To do this, we take the upper limit plus the lower limit and divide by 2. Let's calculate them together. For the first interval, 40 to 45, we add 40 and 45 to get 85, and dividing by 2 gives us a class mark of 42.5. For the second interval, 45 to 50, the midpoint is 47.5. For the third interval, 50 to 55, we get 52.5. And finally, for the last interval, 55 to 60, the class mark is 57.5. Now that we have these midpoints, we are ready to move on to the next step, which we will see in the next slide, where we'll multiply these marks by their frequencies. Real-world example continued. Now that we have successfully calculated our class marks in the previous slide, let's move on to steps 2 and 3, where we calculate the product of the frequency and the class mark, and then find their total sum. If you look at our updated table, we are taking each frequency, which we call f sub I, and multiplying it by its corresponding class mark, which is x sub I for the first interval, 40 to 45. We take the frequency of 5 and multiply it by 42.5, which gives us 212.5. Moving down the table, for the next interval, 10 times 47.5 equals 475. For the third row, 8 times 52.5 gives us 420, and for the final interval, 7 times 57.5 results in 402.5. Once we have all these individual products, we add them all together. This gives us our total sum of f sub I times x sub I, which is 1,510. Next, in step 4, we need to identify our total frequency. By adding up all the students in each group, we find that the sum of f sub I, or the total number of observations, is 30. Finally, we reach step 5, where we apply the direct method formula that we discussed earlier. We take our sum of f sub I times x sub I, which is 1,510, and divide it by our total frequency, which is 30. When you perform this division, you get approximately 50.33. So, our final answer is that the mean weight of the students is approximately 50.33 kilograms. Now, before we wrap up, let's take a moment to look at some common pitfalls to avoid during these calculations. Common mistakes to avoid. First, please be careful not to use the class limits instead of the class marks. A very frequent error is multiplying the frequency by either the lower or the upper limit of the interval. Remember what we discussed in the earlier steps. You must always calculate the midpoint, which we call x sub I, first, and use that value for your calculations. Second, watch out for calculation errors during multiplication. As you saw in our weight example, class marks often involve decimals, such as 42.5. When you are multiplying the frequency by these decimal class marks to find f sub I times x sub I, it is very easy to make a small slip-up. I strongly advise you to double-check these individual products before you move on to the summation. Finally, do not confuse the total frequency with the sum of the class marks. When you are at the final step of the formula, ensure you are dividing by the sum of f sub I, which is the total number of observations, and not by the sum of all your x sub I values. Now, before we wrap up our lesson, I want to pause and discuss some common pitfalls. Even when you understand the logic of the direct method, it is very easy to make small mistakes that can lead to an incorrect final answer. If you can avoid these 3 mistakes, you will find that the direct method is a very reliable tool. Let's move on to our final slide to summarize everything we have learned today. Key takeaways. All right, we have reached the end of our lesson. Let's quickly recap the key takeaways to ensure you have a solid grasp of the direct method before you move on to more advanced topics. First, remember that the direct method is the most straightforward and intuitive way to find the mean when you are dealing with group data. It's your go-to method when you see data organized into intervals. Second, the core of this method relies on the class mark. As we discussed in the earlier slides, since we can't use a whole range of numbers in a single calculation, we use the class mark, that midpoint we calculated, to act as the representative value for every observation within that specific interval. Third, keep the formula at the front of your mind. The mean, which we denote as x bar, is calculated by taking the sum of the products of the frequencies and the class marks, which is written as the sigma of f sub I times x sub I, and dividing that by the sum of all the frequencies, or the sigma of f sub I. Fourth, a quick tip for your exams. This method is most efficient and easiest to compute when the numerical values of your frequencies and your class marks are relatively small. If the numbers become extremely large, you might eventually encounter other methods, but for now, the direct method is perfect. Finally, always keep in mind that the result we get is an approximation. Because we are assuming that all the data points in an interval are concentrated exactly at the midpoint, we are essentially smoothing out the data. Therefore, the mean we calculate is an estimate of the true average. Great job following along today. Keep practicing these steps, and you'll master this in no time.